Now, we have taken things and multiplied them out, right? We have taken two things that look like this and multiplied them out, right? Right?
Yes.
Yes. This is called factored form. So what factored form means is that it's broken into pieces that are being multiplied together. Okay? Do you see the two pieces that are being multiplied together?
No.
The first parentheses times the second parentheses, right? Okay. So I want you to think about something with me for just a minute. And I'm going to come back to this example. Let's say I have two things, an x and a y. And I multiply them together. And when I do, yeah, I'm going back to that problem in just a second. When I do, I get 0. Even though you don't know what x and y are, tell me what has to be true. One of those has to be 0. One or both of them, right? The only way to get 0 when you multiply two things together is if one or both of them is 0. Do we all agree with that? That is what we call the zero product property. Okay? And it basically says that if two things, product means multiply, if two things multiply to give you 0, then either this one is 0, or this one is 0, or both of them are 0. Okay? That is the zero product property.
Not yet.
So let's go back to that problem that I put on the board initially. Let's go back to that original problem. Let's say in this factored form that I told you that x plus 3 times x plus 2 equals 0. Do you agree, take your hood off, Gavin, do you agree that I have two things multiplied together to give me 0?
Yes.
Yes, right? You told me I had one parenthesis times another parenthesis, right? So, by the zero product property, when two things multiply to give you 0, what do you know? Y'all can do this. One or both of them must be 0. So that means that this one is 0 or this one is 0. Do you agree with that? Yes? Okay. So if I were asked to solve this for x, then what I would do is set each one to 0. And how do you get x by itself here? Subtract 3. And how about the other one? Subtract 2. This one has two answers. Those are the solutions. Those are what x equals. Let's plug it back in to see. So somebody said it didn't make sense. Let's plug it in so that you see. If I plug in -3, okay, because remember when you get a solution, if you plug it in, it makes the equation true. So if I plug in -3, then I get -3 plus 3 times -3 plus 2. And the question is, does it equal 0? Well, what is -3 plus 3? 0. What is -3 plus 2? -1. What is 0 times -1? It works. Okay? Let's try the other one, though. Let's try the -2. Because both of them are solutions. What's -2 plus 3? 1. What's negative 2 plus 2? 0. Does that work?
Yes.
They're both solutions. They both work when you plug them in. Okay?
This is all we're gonna do?
No.
Oh my gosh.
But let's do an example now. You about get on my nerves.
Ain't no outline.
All right, let me give you an example. Let's say that I have x minus 5 times x minus 1 and it equals 0. And I ask you to solve. To solve.
I wonder if they
You
have a
make the x
basketball
by
on
itself.
Sunday.
First you make the x by itself, then plus 5, and then plus 1, 2.
So we set each parenthesis equal to 0, right? Because we have two things multiplied together to give me 0. X minus 5 times x minus 1. Each of those multiplies to give you 0. So by the zero product property, if two things multiply to 0, then one or both of them must be 0. So x minus 5 must be 0, or x minus 1 must be 0. How do you solve that for x? What about the first one?
Minus 5. Plus 5.
Plus 5. So x equals 5 is one solution.
And then plus 1.
Plus 1. Is another solution, right? Does that confuse anybody?
Nope.
No, it's not you.
5 minus
Of the lesson today.
Oh, it's not called that.
It's another part. All right, so here's what we're going to do.
Leave my finger.
Well, you don't have to plug it in each time. I was just showing you why it worked.
Leave it like that?
Mhm.
I would have to plug it in.
That's fine. All right.
No, what's
Now, sometimes we have to make it look factored because sometimes it's not factored when we start. And this will be the whole rest of chapter 8. We're going to start out easy today with factoring by just factoring out a GCF. So do y'all know what a GCF is? Good job. Greatest common factor. Common factor. So, you know what the acronym stands for, but do you know what it is? What is a greatest common factor?
What's the numbers halfway?
The highest number that goes into both of them with no remainder. So if I asked you to find the GCF of, let's say, 24 and 16.
The largest common factor is 8.
It's 8.
For what number?
For both of them.
For both of these, because what you're thinking is you're thinking about the factors of each one. What can you divide each one of them by evenly? Well, the factors of 16 would be 1, 2, 4, 8, 16, right? And the factors of 24 would be 1, 2, 3, 4, 6, 8, 12, 24, right? And so the biggest number they have in common would be 8. Does that make sense to you? How about the GCF of 2 and 8?
2.
2. You don't divide them by each other. You're looking for the biggest thing that divides into both of them. How about, you know, I'm fixing to kick it up a notch. Because y'all have done this before.
Yes.
I ain't never did this before.
What is the GCF?
Why you got that?
Close. It is 7, but it's 7 times something.
Why you got that?
7x. Okay?
What?
Notice, if they share a variable, then that's part of the GCF. Then no, it would have to be the same one because it's all about what they have in common. How about if it was,
So they had different variables. You want to put like both of them?
like for instance, if this was, sorry, GCF. Actually, I shouldn't have put the plus in there just yet. We're not ready for that. Oh my gosh.
Is it,
You could have.
is it,
What's the GCF? 6 is correct. No, because it's common, greatest common factor. So the first one has an X, but the second one doesn't. The second one has a Y, but the first one doesn't. Nope, you can't. They have to both have it in order for it to be a GCF. How about? Yeah, I'm fixing to show you. We're gonna make the connection in just a second. How about this? What's the GCF? 4. I heard X, even bigger. 4X to the what power? The first one's got how many X's? How many X's does the first one have? 4. How many X's does the second one have? What's the biggest number they have in common?
1.
All right, look. The first one is 4 and then 4 X's, right?
Yes.
The second one is 24 and 3 X's. We know that 4 is a GCF. How many X's do, yes. This, you just said it.
Yes.
This one's got 3 X's and this one's got 4 X's. So what's the greatest amount they share?
Oh. So there's 3
3.
inside of
Because
that.
there's 3, that one has 3, right. Okay, so it's 4x to the third power. Okay, now the question has been raised, oh my gosh, how are we going to use this?
In life, how we use this?
I'll get you back in a second. All right,
Shut up. Oh my God.
what we have been doing looks something like, let's say I had 2x times x minus 5. Shh. I'm fixing to show you. All right. You would distribute, right? This is what we've been doing. We've been distributing, yeah.
Equals 4x squared and 10, -10.
That's what you've done, okay? What we're going to do now,
Why you got that? Why?
I swear to God.
2x times x is 2x squared, and 2x times -5 is -10x, right? I distributed. That's what we've been doing in this chapter is multiplying, right? Now what we're going to do is we're going to take this and we're going to make it look like this. Okay? Now I want you to notice, I want you to look at these two things. Look at 2x squared and look at 10x. What is the GCF of 2x squared and 10x? 2 what?
2x to the first time.
2x to the 1 power, because this one's only got 1.
Another one has 1.
Okay, it's the greatest common that they share. This one has 1, this one has 2, so what they share is 1. Look on the outside here. What do you notice?
2x.
That's the GCF, right? So we're going to take the GCF, we're going to write it on the outside, and we're going to divide each of these to come up with what's left on the inside. Okay? We're going to find the GCF. Okay. First thing we're going to do is we're going to find, because we're going, instead of going left to right, we're going to go right to left. Gavin, how are you going to remember this if you're asleep? First thing we're going to do is find the GCF. Okay? It's going to go on the outside. Okay? Then, to find what's on the inside, we divide by GCF.
So you do 2x squared divided by 2x.
That's how we come up, right, because we're going, I should say, we're going backwards of multiplying. And what's the backwards of multiplying? Division. So that's what we're doing. I need you to pay attention now. But I always do, every day.
Alright, so what we gonna do?
All right. So look, we know what it's going to be, but let me show you since this example's up here. Let's say I have 2x squared minus 10x, and I said factor out the GCF. So your first step is, well, what's the GCF of these two numbers? 2x, okay? You're going to write it on the outside, the GCF.
Oh, the outside of what?
The outside, and we're going to make a parenthesis. Now divide. What is 2x squared divided by 2x? Yeah, that's right. 1x, right? If you want to write the 1, you can. Okay, and what is 10x divided by 2x? Negative 5. It takes the x's away, right? If you need to come right here and say 2x squared divided by 2x is, remember we subtract x, that's how you get that one. I was just showing you what we did before. I just used the same example. It does because 10x divided by 2x, the x's cancel, and 10 divided by 5, 10 divided by 2 is 5.
Wait, so at the beginning, you did this at the beginning, or you just showed us
I'm just showing you what we were doing compared to what we're doing now. What we were doing was multiplying. Now we're going to go backwards and do the dividing. I'm going to show you plenty more examples. All right, take a look at this one. I told y'all this is going to be a little tough, okay? I need y'all to stay with me. 4x to the 4th plus 24x to the 3rd. I want you to factor out the GCF. You're learning how to do it. You haven't forgotten. You're learning. All right, yeah.
So what we do?
What is the GCF? GCF is 4x to the 3rd power. Does everybody see where that came from? Gavin, sit up.
Yes. No, not really. Wait, yes. No. It was on the board though.
We already did this one.
It's on the board right there.
Yes.
It's on the dry erase board.
This is one of the examples we found the GCF of. All right. 4x to the 3rd. So, take the GCF and put it on the outside.
Okay.
Now, what's left inside? Now, look what I had.
I don't even know.
All right, listen. Divide each one by the GCF out there. If you divide 4x to the 4th, divided by 4x to the 3rd, what do you get? Somebody said it. X.
Oh, yeah.
Look, we're taking this GCF and we're dividing it into each one. For the first one, 4x to the fourth divided by 4x to the third. Yep.
Don't you subtract that?
Yep. 4 minus 3 is what?
Oh, no.
And what happens when you divide 24x to the third by 4x to the third? It becomes 6.
Wait, wait, just become 6.
Just 6. Divide them out and look. 24x to the third divided by 4x to the third.
Okay, Mr. D, I'm kind of confused because
Okay.
on this one here, look. We actually had an equation, and then we did that find that equation.
No. I was just showing you this is what we've done. Now we're going to be doing this. We're going to make these into equations eventually. We're just working our way up to that.
So working our way until next.
Right now, I want you to factor out GCFs. I don't think we're going to solve much today. All right, leave it like that. All right, let's do another one together. Together, everyone.
No.
Factor out the GCF. Factor out the GCF. Come on. Guys, that is not what we're doing. Factor out the GCF.
Alright, so is it
It's what? 2x.
2x? I think it's 2x.
That's correct. Why is it not 2x to the second power? The last one only has one x. It doesn't have two of them. All right, so we put the GCF on the outside. What's left? X. Yes. Good job, Shaisha. Listen, if you distribute it back out, it should come back to what you started with. Right?
So it'll be 2x, 2 boys.
Right.
Plus 8.
X, right. Okay, good grief. X squared. Actually, let's use another variable. Why are you laughing? Because I yelled at you?
I am sensitive because I just cried when my mama yelling at me. Me too. But then when she yelling.
What is the GCF here?
1.
A to the first power. 1a to the first. You're both right. How do you know that? The biggest thing you can divide everybody by is 1. And they also share an A. Let's put that on the outside. What's left inside? A plus 5. Yes.
Mr. G, what if both of them gone? Mr. G, what if it was D?
What if both of them, let me show you one. Let me show you one that uses both numbers.
What if it's 1 without no number? Like just a variable? Yeah. It'd be 1 in front of it.
Yeah, there's a 1 in front. Let's say I had 9s squared minus 3s. And I want the GCF factored out.
It's not,
What is the GCF here? 3s. Yep. All right. GCF goes on the outside, right?
Yeah.
What's left inside?
3s.
3s.
1s.
Minus F.
You were right the
1.
first time.
1.
Minus 1. Remember, what we're doing is dividing. So if you divide anything by itself, what's left? 1.
You have 1?
That's all we have to do.
Let me see if you really understand. What's the GCF?
7.
Nah, it's 7.
And divide.
The second one's got an N, not an M.
This would be 7. Please.
So it's just 7. So what's left when you take that out?
7.
7.
Yeah, that's right, Zaya. 2.
Oh, now
M, because the M's still there,
you
right?
don't have an M with
Yeah, plus what?
5.
5N.
Oh, why you add wait now?
That's the answer.
They were different variables. Remember y'all asked, what if the variables are different?
Oh.
If the variables are different, it's not a GCF. Another.
All right, DJ Cal.
You know I'm going to make it harder as we go.
Oh.
Oh my goodness. Cranking it up a little bit.
Oh, I got to Alright, great. Comes back to 5. No, 4.
4, don't divide them. It's the biggest thing that goes into both.
4 is 1.
4xy, that's right. Because this one's got 2 x's and this one's got 2 y's. But this one only has 1 of each. So put that on the outside, right?
Equal 5.
What's left? Look at the numbers in front first. 5,
X1.
x, y, that's right.
And 1 X1. 1 X. 1. 1.
You took an x, y out.
Oh.
So it's just minus 1. Remember, if you start getting confused, okay, if you start getting confused as to what's left, look, take each one and divide by the greatest common factor. Anything divided by itself is 1. If I did it with the 20, remember when we did those properties of exponents? 20 divided by 4 is 5, and we subtract when I divide. 2 minus 1 is 1, 2 minus 1 is 1. Y'all are not even listening to the explanation.
I was